Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 4th, 2026, just 6 days ago. It demonstrates that by optimizing a model's internal attention rather than just its output tokens, researchers achieved a 94-point jump on the MME benchmark compared to standard methods. The paper is titled Reinforced Attention Learning. And as we'll see later, this shift in focus offers a really promising alternative to standard reinforcement learning for multimodal models. So Figure 1 illustrates this core distinction conceptually. The top panel depicts the traditional token probability policy, where the model optimizes the likelihood of generating specific words, focusing purely on what to say next. In contrast, the bottom panel presents the proposed attention distribution policy. Here, the learning signal adjusts the internal attention weights, represented by the lines connecting the current word back to specific image or video tokens, effectively teaching the model where to look to find the right answer. Well, to implement this, the researchers first need to structure the model's output. Figure 2 shows sample data for the training stages, illustrating the think and answer paradigm. The top block displays a standard multimodal prompt asking a question about visual content. The bottom block then reveals the target response, where the model generates a reasoning trace inside think tokens before stating the conclusion within answer tokens. This structured format, established during supervised fine-tuning, allows the reinforcement learning stage to verify both the reasoning process and the final result. Alright, with the training data structured, Table 1 details the specific hyperparameters for the experiments. It lists a rollout batch size of 8 and a KL coefficient of 0.04, which helps keep the policy updates stable. The table also highlights the sweep values for the attention-specific terms, lambda and gamma. Finally, the text below confirms that the authors benchmark their results against Group Relative Policy Optimization, or GRPO, to validate these gains. So, having established the setup, Table 3 presents the main results across 8 image benchmarks. Notice the middle block where standard reinforcement learning methods, such as Video R1 and GRPO, actually struggle. They often perform worse than the base model on perceptual tasks like VizWiz. However, RAL reverses this trend. It sweeps the board, outperforming GRPO on every metric, with notable jumps to 73.3 on versus STAR and over 2350 on MME. Okay, expanding beyond static images, this table reports performance across 7 video benchmarks, including Long Video Bench and NextQA. In the reinforcement learning section, notice that RAL consistently tops the charts, achieving 60.1 on Long Video Bench. What is particularly striking is RAL0, shown in the 4th row. It optimizes attention without explicit reasoning tokens, yet still surpasses standard methods, hitting 76.2 on NextQA, which implies that correct visual focus often matters more than verbalized logic. Now, while the previous table showed average scores, Figure 3 breaks down performance by visual density to see how these models handle richer information. The left panel tracks Long Video Bench accuracy as input frames increase from 32 to 128. RAL, shown in blue, consistently outperforms the GRPO baseline in purple. The right panel reflects the versus STAR benchmark across rising image resolutions. Crucially, at 2048 tokens, the gap widens significantly, suggesting that RAL is far better at exploiting high-fidelity visual details. So ultimately, this paper suggests that for multimodal models, we shouldn't just reward the final answer, but also the visual focus that leads to it. By treating attention as the policy itself, the authors show that teaching a model where to look is a powerful way to improve perception. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.